this is the last presentation, but I wanted to introduce a combination of a couple of technologies as well as voice services for the next generation electronic health records. This is a product which is there in the market. We have been using this as healthcare analytics, and we are in the process of getting the data and optimizing the networks as part of it. So my research group includes my CEO Hanumayamma and my product manager Santosh Kedari, who is leading in India, and Jay and Sharad, we are in the US, and Mahesh. So let's start the presentation. Now, the goal here is very straightforward. Now, as we see, right, voice service technologies are becoming very popular. Voice service technologies that includes now voice service enabled services such as Alexa, as well as SiriKit, which is from iOS, and Microsoft Cortana. There is a lot of voice data being generated using user mobile phones as well as the desktop systems. So one argument what we found was including those data points as part of electronic health record has a huge benefit for a patient care. That's what our product is and our research is, and it's proving to be very, very useful because the mobile phone, as we know, right, it can capture basically a contextual as well as lifestyle data, which is very valuable when you're talking about covering the user, covering the patient with respect to the healthcare options. So as you know, right, as I say, Alexa services, we have SiriKit, Cortana, and Google Home. These are all very intelligent devices, AI-enabled devices. They collect a huge amount of data, and the data, the goal of our project is including with the EHR. So our goal is very straightforward. We wanted to provide a proactive, like today morning, there was a keynote speech from IBM. She was clearly mentioning the goal of Dr. Watson is to provide a proactive, rather than before a person get hospitalized proactively, you can advance them. That gives a cost benefit to the state, cost benefit to the family, cost benefit to everyone. Everyone is a winner in the game. The preventive process is, I know, based on the user medical history, demographic history, family history, we can provide a preventive analysis. Again, that also helps a lot. More importantly, prognostics. This is where we can provide, hey, watch out, this spring season is coming. Historically, given the allergies, you may get attacked by the prognostics. So these are the enablements using the voice services. So then one reason we found through our research as well as market research, huge number of devices are being sold, and this is a traditional way of looking at devices, voice services devices, that includes a combination of both across the platform, Alexa to SiriKit. 2014, very minimal. 2017, almost hitting 35 million devices user. Now imagine now how much data these devices can generate and how valuable for the users. Now, this is a Medicity news. There's a great potential for healthcare through Alexa. Alexa-enabled services will provide a huge points for patient care. Our goal is very straightforward, as our theme is interweaving the voice-generated data with the EHR and using the data science. Our pitch is using the data science to create a new clinical pathway. That is, you have a EHR data, you have a data from the voice services. Now you apply on top of it machine learning, you apply on top of it a social ambient intelligence to generate a new clinical pathways. The plus point, doctors will identify new solutions using data, data being a medicine in this part of the game. Now, as I said, we have a voice services. These are the data generated sources. Now, here is a user electronic health record, and this is the data science part. We want to combine across all the verticals to create a huge platform for the patients. Now, how we are doing? Again, we are working with the SiriKit, and SiriKit provides a huge data collection, especially either you take the SiriKit or VoiceScape that generates a good amount of data. What we do is we take the amount of user data and we move the data to the cloud and use the data to all in SiriKit mobile app itself to run a contextual analytics to provide a user the medical or actionable insights. Now, this is our app. Again, this is a traditional Siri kit, and this is the code we are going through. Again, Siri kit provides whatever a user talks, the data can be converted into the cloud-based asset. Now, second one, again, Alexa. Alexa, very well known AI intelligent device. Alexa provides a huge benefit to retrieving the data. What we did was we deployed Alexa app services in Amazon Cloud, and that basically using Alexa services, user can provide. User could be end user, a old citizen, or patient. They can provide the data points. Apart from that, right, we are using a machine learning that includes the data from World Health Organization data, demographics data, as well as electronic health record data, clinical trials, and combining that with different modalities of, I would say, machine learning artifacts or machine learning algorithms. For example, decision tree. Now, this is a classical data, user data. Now, we analyze the data from the couple of users. We run clinical surveys and healthcare surveys, healthcare camps across the world, especially in India, other places. We get so much data from the users. After observing the user patterns, we could able to identify what is the next step, actionable step that we can provide to the user. And this is one of the decision trees that we collected from the users, and we recommended them the next best healthcare options, not replacing doctor, but augmenting the doctor as we discussed today. Now, second one, we apply the most important thing, the machine learning algorithm called term frequency, inverse document frequency, which is the part where, based on the user conversation with the voice services, we will immediately identify what is the item he or she, in the case the user or a patient looking at. This is where TF-IDF, term frequency, inverse document frequency will come. A good example, we take the doctor notes that the doctors provide, we run through our machine learning algorithm, and we know the key words that user looking at. For example, a senior citizen, it says, I'm being suffocated, or I am feeling low energy. Based on the medical history, we'll immediately recommend to the patient care to reduce any kind of health incidents. Third factor we apply is on top of it, cosine distance, again, under machine learning process. All we found it is based on the user profile 1, user profile 2, we identify how closely these users are together so that we can recommend a medication to them. For example, in this case, you have a patient 1 to patient 4, and